This is the PPR Operator Training Instruction for fasteners. In this instruction you will learn the types of fasteners in use here at PPR, as well as the tools and methods used to install them. Fastening technology is a very important part of the PPR remanufacturing process. Fasteners are what hold our product together. As a valued employee, it is vital that you understand the tools and techniques used to make PPR products some of the best in the industry. Fasteners come in all shapes and sizes, but in order to successfully remanufacture product that meets the needs of PPR customers, we must be able to identify the various types of fasteners and how they are sized for application. Bolts and screws, rivets, washers, nuts, all are found in PPR processes. Let's look at each of these fasteners individually and how they are used in the PPR process. Let's begin our look at fasteners by examining the most common fastener in use at PPR, bolts and screws. Bolts and screws are threaded fasteners and come in many shapes, sizes, and colors. When choosing a bolt or screw to hold PPR product together, it is important to choose the correct size for the application. The first attribute to be aware of when specifying or using a bolt or screw is the major diameter. When referring to a bolt or screw, it is the major diameter that is the first thing specified. For example, if you are using a number 4 screw, the number 4 designates the major diameter of the fastener. The next thing you need to know about a bolt or a screw is the thread pitch. The thread pitch specifies how the threads are distributed along the shaft of the screw. In most cases, the thread pitch is specified by the distance between each of the threads as shown on the screen. If the major diameter of the screw or bolt is correct, but the thread pitch is incorrect for the hole, the fastener will not work. You have to know the thread pitch of the hole and the fastener, and they must be the same. The next attribute of concern is screw length. The length is always measured from the base of the head to the end of the bolt or screw. The length of a bolt or screw becomes very important when thread engagement is a factor, or when interference with an obstruction is a consideration. Too long a screw may cause rubbing or an electrical failure, while a bolt or screw that is too short may not have sufficient holding power. The last consideration when choosing a bolt or screw is the head type. Bolts and screws come in a variety of different head types. We will look at these more closely in the tooling portion of this program, but we must be aware of the different types and know how to recognize them. We also need to understand that not every head type is suitable for every application. Just because a screw fits does not mean it is suitable for the application. Bolts and screws are specified first by the major diameter, then by the thread pitch, then the length, and finally by the type of head. The next fastener type we will examine is the nut. Like bolts and screws, nuts are threaded fasteners and are common in the PPR process. Nuts, like bolts and screws, come in a variety of sizes, shapes, and colors, and must be carefully chosen for the application. Let's examine these critical fasteners more closely. Like bolts and screws, the first attribute of interest in selecting a nut is the internal diameter. Because nuts are designed to mate with bolts and screws of corresponding size, a nut must have the proper internal diameter to fit the bolt or screw. The next attribute of interest in a nut is the thread pitch. Like bolts and screws, nuts have a specific thread pitch. It is often impossible to tell the thread pitch of a nut simply by looking. It is a good idea to get in the habit of checking the thread pitch to make certain the nut is sized properly for the application. An impact wrench can often force an improperly pitched nut on a shaft, with catastrophic results. The next element of interest is the nut thickness. Nuts of identical internal diameter and thread pitch may have differing thickness depending upon application. The final attribute of concern on nuts is the tool size. The required tool size is determined by the outside dimensions of the nut. It is critical that the proper tool be used for nut installation and removal. We will examine tooling issues more closely later in this program. The next fastener we will examine is the washer. Washers are used along with bolts, screws, and nuts to create good fastening systems. The three types of washers you will encounter most often at PPR are the flat washer, the lock washer, the star washer. Like bolts, screws, and nuts, the first attribute of interest when selecting a washer for a particular application is the diameter. In this case, the inner diameter. It is the inner diameter that determines whether the washer will fit the bolt or screw. The next most important attribute is the outer diameter. It is the outer diameter that determines if the washer will fit under the head of the bolt or screw. Flat washers are designed to spread the clamping force of the bolt or nut over a larger area, while lock washers and star washers are designed to provide resistance to rotation of the bolt or nut. In order to accomplish either of these tasks, the washer must be properly sized for the application. Washers are also available in various thicknesses, depending upon application. The last fastener type we will examine in this program is the rivet. We use two types of rivets in the PPR process: the pop rivet and the tubular rivet. Rivets are used when a threaded fastener is not appropriate for the application. PPR primarily uses rivets in the rectifier area. Rivets are assembled using either a rivet gun in the case of a pop rivet, or an arbor press as shown here. You will notice that the rivet installation process produces a solid connection between the assemblies, and in this case it also provides an electrical connection. Now that we have examined the type of fasteners likely to be encountered in the PPR process, let's look at some of the details we have to address when installing fasteners in PPR product. The first thing we have to be aware of is the fact that there are standards for threaded fasteners. Most of the threaded fasteners you will use at PPR will have a metric thread. The metric standard is used worldwide, and since PPR specializes in remanufacturing alternators and starters produced outside of the USA, most of our product is based on the metric system. Metric threads are designated by an M in front of the major diameter, such as M4, M7, or M14, followed by the thread pitch of 0.7, 0.8, or 2. These numbers represent a measurement expressed in millimeters. But you should also be aware that there are other standards you are likely to encounter during the remanufacturing process, such as the British Whitworth Standard and the American Unified Standard. While threaded fasteners adhering to these other standards are not seen as often as metric threads, they are still frequently used at PPR. In most cases, when these less common threads are called for, they will be specified in the production work order for the lot. This is an example of a PWO specifying American Unified threads. Now, let's look at tools. The most basic tool available for installing a screw is the flat blade screwdriver, or bit. The blade is designed to fit completely within the screw head, as shown. The blade should completely fill the slot, allowing little to no movement. PPR stocks two sizes of flat blade bits. It is important to select the properly sized bit for the screw being driven. It is equally important to monitor the wear of the bit and to discard it when worn. Flat blade bits tend to wear at the corners. Discard the bit when it no longer seats properly in the slot. The next tool we will examine is the Phillips bit. The Phillips screw is probably the most common fastener used at PPR. Therefore, the Phillips bit is one of the most often used tools. PPR stocks three sizes of Phillips bits for three different sizes of screw. The number 1 Phillips for relatively small screws. The number 2 Phillips is the most often used size. And the number 3 for large screws. Be sure to select the proper size bit for the screw. Care should be taken to frequently examine your Phillips bits for wear. A worn bit will not properly drive the fastener and can cause damage to the product or personal injury. There is one other factor to consider when you encounter a Phillips screw. Not every screw that appears to be a Phillips is actually designed for a Phillips bit. The screw that appears to be a Phillips may actually be a posi drive screw. Posi drive screws differ from Phillips in the design, but the design differences are not visible to the naked eye. A close examination of Phillips and posi drive bits reveals the difference. Note the taper of the Phillips bit, while the posi drive bit is straight from top to bottom. When looking at the fastener, you can tell a Phillips from a posi drive by the markings present on the posi drive. When you have selected the proper bit for the fastener, whether Phillips or posi drive, the bit will rest solidly inside the screw, and the rundown will be smooth and solid.
When you have a Phillips or posi bit in good condition, there is a test that you can perform to verify that you are using the proper type of screw. To perform this test, place the screw onto the screwdriver. Now, turn the screwdriver so that it is parallel to the ground. If the screw is of the proper type, it will not fall off. Be aware that the screw will fall off if the screw or the drill bit is worn. Be sure to perform this test to determine if you are using the right screw and the right screwdriver.
Selection of a Phillips bit to drive a posi drive screw, or the use of a worn bit, can cause the bit to cam out of the screw head. In this image, a posi drive bit is being used to drive a Phillips screw. The result is a cammed out screw head that fails to meet PPR standards. The final tool we will examine today is the socket. Sockets are used to drive down nuts or hex drive bolts. There are two basic concerns with regard to sockets. The first being to ensure that you have the appropriate size socket for the fastener. And the second is to make sure that the socket is not worn beyond use. PPR stocks sockets in both American and metric sizes. The proper size socket is determined by the measurement across the flat sides of the nut or bolt. Make very certain you are using metric sockets for metric nuts. Failure to do so can result in damaged product and tooling. Contact your lead or supervisor if you have questions about what size socket to use. Finally, we come to the question of torque. Torque is the force applied to the fastener that gives it its clamping power. We torque fasteners because we wish to control the amount of clamping power we exert on the product. Too much clamping power, and we may strip the fastener or cause damage to the product. Too little clamping power, and the product may not hold together. The application and control of torque can help us be more consistent in our tightening operations. PPR specifies torque in Newton meters. 1 Newton meter is approximately equal to 3/4 foot-pounds. PPR uses Newton meters as a standard because it is the metric designation for the specification of torque. PPR engineering uses the production work order to communicate to you the torque specification for fasteners. This particular PWO is calling for the through bolts to be torqued to between 4 and 6 Newton meters. PPR uses torque guns to apply the torque to fasteners. Each gun is preset to a specific torque. You must use the correct gun to apply the correct torque. In this case, the orange gun would provide the proper torque. When applying torque to product, it is important to apply the torque in an even manner. One of the best ways to do this is by use of the star pattern of tightening. Using this method, the bolts or screws are tightened opposite each other. This distributes the clamping power equally around the housing. Just as important as using the star pattern is torquing each of the bolts a second time. This ensures a solid assembly.
Here at PPR, we want our remanufactured product